Okay, 7D. We're working out surface areas in 7D. So I've chosen to do question 2 part B. Let's just make some room here. I need some working out space. I've chosen to do this one here. Okay, this is a triangular prism. It's going to be a little bit tricky because it's actually missing a length here, but we'll get to that in a minute. Okay, this triangular prism, if you imagine unfolding it, is made of a triangle, two triangles front and back. Let me write that, front and back is two triangles. And they have a length across of 10 and they have a height of 6. We could call 10 the base, call that the height, because the formula for the area of a triangle is half times base of the height, right? You could actually rotate the triangle and consider the 6 as the base and you'll get the same area. We've also got this side, this right side, call it right side. It's a rectangle and it's 12 long, 12 meters long, and it's 6 meters tall. If you want to call that a width, that's fine. Area of a rectangle, length times width, 12 times 6. We've got a rectangle on the top, and we've got a rectangle on the bottom as well. If we look at the top of the shape, I'm going to draw it like this. It's 12 by 10, length times width. And then we've got this rectangle underneath on the bottom. And we'll have to add up all of these areas to get the total surface area. They've said it here, the total surface area for all of these shapes added together. Now this one here, it's actually missing a measurement, right? Because for the bottom rectangle, I need to know that length there, and they haven't given it to us. Right? But we'll come back to that. Okay, the two triangles front and back. We've got two lots of half base times height. Okay, half of a base of 10. Half of 10 is 5. 5 times 6 is 30. We've got 2 30s is 60 meters squared. All right, the right side triangle. Length times width, 12 sixes is 72. The top, sorry, did I just call that a triangle? That's a rectangle. The top rectangle is length times width, 12 times 10 is 120. And we also need the bottom rectangle area. Now, we've got this triangle here. I'm going to draw it slightly differently. I'm going to rotate it. We know, what do we know? We know that's 6 long. We know that's 10 long. We need to work out this. We're going to use Pythagoras. So here's another triangle with A's, B's and C's. A, B, C. And Pythagoras said if you square all the lengths, then the sum of those two squares of the short sides will equal the square of the long side. He said C squared is A squared plus B squared. I like to write it this way. C equals the square root. So I put the square root in right from the start to get to the answer quicker. I can put that into a calculator. So that length there would be the square root of 10 squared plus 6 squared. Okay, I've got a calculator here. It's the square root of 136, which is 11.66. Let's just say it's about approx 11.7. Right. Now calculator time again. What's the area of this rectangle? It's 11.7 times 12. It's approximately 139.9. How about we just round it up? Let's round it all the way up to 140. So it's approximately equal to 140 meters squared, right? The total is approximately equal to all of these numbers added together. So 140 plus 120 plus 60, I'm doing this in the calculator by the way, plus 72, and I get approximately equal to 392 meters squared, right? Then you should go to the answers. It was question 2B. We're doing 7D. 7D, 2B. There it is. All right, we could have used some more decimal places. The book didn't and I didn't. But if you've got some decimals, you might have 391.9 something. That's fine, because the question doesn't actually tell me how many decimal places. Right, I'd like to look at one more. It's a bit harder, I think. Although that one was a little bit involved. It's the Taylor prism, and it's a hexagonal prism. Oh, thank you, John. Sorry about that. So this is a hexagonal prism. Let's just think about the shapes. We've got a hexagon on top, a hexagon on the bottom. Let's draw a hexagon over here. Hexagons. Okay. It's actually a regular hexagon. All those lengths are the same length. And these hexagons do have some nice properties. For example, I get 6 equilateral triangles. Apologies for my terrible drawing of these triangles. But you're not really expected to know that. When you have a regular hexagon, there's things like the length across the middle here. That length there is 2 times this length in here. So if you knew that, you could actually simplify the question of working out the area, but we're going to assume that we don't know that. Now, the rest of the shape, we've got these rectangles. How many rectangles on the sides? We've got the side rectangles. Side. There were 6 of them, weren't there? 6. This bit should be pretty easy. Length times width, 38 times, what's the width of one of these rectangles? It's 8.5. In fact, why don't we work out that area right now, and then we'll look at the hexagon again. So 38 times 8.5 equals 323. Then I times it by 6, and I've got 1,938. And we'll just keep that number for later when we have to add up to get our total. 1938. Okay, it was a good year. Okay, back to this hexagon. All right, can you think of this hexagon as being made up of 2 triangles, there and there, and 1 rectangle? I think that's the way to do it. You can also think of a hexagon as being two trapeziums. Imagine another trapezium underneath that. And what shape have you got? Ah, a hexagon again. But that's not going to help us for this question, unfortunately. Well, it could, but you'd have to know that this length here works out to be 17. And I'm not even sure, I think they might have rounded off some of these numbers. I'm not, yeah, well, Anyway, let's start with the rectangle in the middle. And I can see that the book in the answers is doing a bit of approximation, so we might end up with a slightly different answer depending on how we tackle the area of the hexagon. But, you know, close enough is good enough for these questions. As long as you're within 1 or 2 square centimetres, then that's probably okay. And you show you're working out. So I've just gone to my calculator, and the area of that rectangle there, it was about 125. It was actually 124.95, but we're going to do a bit of rounding, I think. So we've got that part of the hexagon done. Now we've got to worry about these triangles. They are the same size because it's a regular. So imagine we had one of those triangles. Okay. And we wanted to know its area. Now that was just so badly drawn, I'm going to do it again. I'm taking this triangle and I'm rotating it, enlarging it a bit so I can write lengths on and whatnot. Now I know that this length here was 14.7. I've got it written there, right? So that's 14.7 the whole way across. That 8.5, that fits on the sides of the triangle. There and there. But I've got a problem now because the area of a triangle is a half times the base times the height. And we're missing our height. Okay, but Pythagoras can help me find it. So if you recall your ABC triangle, A, B, C, how would I find a short side? Well, if C squared is A squared plus B squared, this is the Pythagorean rule or theorem. If I wanted to work out a short side, like this height, it's a short side of this right-angled triangle. Draw a little right angle in. I'd have to rearrange the formula and subtract away from the long side. Or I could say this and square root right from the start, like so. Okay, so let's get that height. I'm going to need a calculator. The height is going to be the square root of, now I only want, I'm just looking in, this is our right angle triangle in here. It's actually only half of these two triangles that's in the diagram. So if we half 14.7, we'd get 7, what am I doing? This isn't right. We need to start with the long side. The long side is the 8.5. 8.5 squared minus half of this 14.7 would be 7.35 squared. And I get a height equal to what? Calculator. Square root 8.5 squared minus 7.35 squared equals 4.27. 4.27. So that height is 4.27. It means the area of the triangle would be half of the base, oh yeah, I worked that out before, times that height. So it'd be 7.35. 7.35 times 4.27, and I'm getting 31.37. Let's make it 0.4, make it approximate. Now, in the hexagon, we had two of those triangles. So the hexagon area, it's two triangles, two 31.4s plus that rectangle, 125, and that all comes to what? So 31.4 times 2 plus a 125, I get 187.75, 187.8 approximately. I think my rounding's tending to go up. Maybe my answer might end up slightly higher than the book. Well, who knows. So back to where we're working out our total surface area. I'll write the total here. We've got all the sides. We did that. That was easy, rectangles. We've now got the area of a hexagon, but our shape has two hexagons. So we need to go plus 2 hexagons, right? Which is 2 lots of 187.8. Right. Now if I just do the 2 times 187.8, I get 375.5. 375, these are approximate answers, and a half centimetres squared. Add that with the previous area. So if I write total surface area equals this number plus that number, so it's plus 1938, and I'm getting 2313.5. 2313.5 centimetres squared. Right. If I just delete everything for a minute because I want to check the answer. 2313.5. What's the book got? This is question 6. Well, they said approximately 2310. Right, so they've rounded to the nearest 10 for that question. And yeah, that's acceptable, okay? So like I thought, there was a bit of approximating going on there. If it was me, I'd just leave the answer like this, unless it tells you. Does it say to write to the nearest 10? Not really. Okay, thanks for watching, guys.